Okay, so imagine this. Your commute, right? But you're not driving, you're working. Or maybe a road trip with 0 gas stops. Or, get this, a weekend trip to the moon.
Yeah, it sounds like sci-fi, doesn't it?
Yeah.
But it's really not that far off. It's where transportation is heading.
Exactly. And that's what we're diving into today, these huge shifts. Autonomous vehicles, electric mobility, and yes, commercial space travel.
And they're not really separate things, are they? They're all connected, intertwined, poised to really change how we get around, how we live.
Totally. So we'll look at where things stand right now, like May 2025, what's driving it all. I mean, transportation is nearly a quarter of global co-Euro emissions. That's a huge factor.
Definitely. We'll cover the breakthroughs, the cool advancements, but also, the real challenges that are still there.
Right. The goal here is pretty straightforward. Give you a clear, engaging picture of this future of transport, what's actually important right now, and crucially, what it means for you.
So let's kick off with autonomous vehicles, AVs.
The self-driving cars.
Basically, yeah. Cars that navigate without a person needing to intervene. They use all sorts of sensors, cameras, radar, LiDAR feeding data into, pretty advanced AI.
And there are levels to this, right? Like different stages of autonomy.
Exactly. The SAE levels, 0 to 5. 0 is you doing everything. Level 5 is full automation, anywhere, anytime, no human needed, ever.
And where are we actually at now?
Commercially, you can find level 3 systems. The car handles some tasks, but you need to be ready to take back control. And we're seeing quite a bit of testing with level 4 robotaxis in specific areas.
It's still kind of hard to wrap your head around letting the car completely take over. What's the big promise here? Why push so hard for this?
Well, the potential benefits are just massive. First up, safety. It's a big one.
Right. Human error.
Precisely. Something like 94% of accidents involve human error. So if AVs can just cut that down significantly, we're talking potentially saving thousands of lives.
Wow, 94%.
Yeah, and economically, in the U.S. alone, that could mean savings around $190 billion a year just from fewer accidents.
That's staggering.
It is. And then there's accessibility. Think about older people, people with disabilities, anyone who can't get a license. AVs could give them freedom, mobility they just don't have now.
That accessibility point feels really important. So what tech developments are actually making this happen? What's getting better?
Okay, so several areas are really pushing forward. Sensor tech is improving all the time. LiDAR, that's the one using light pulses for 3D maps plus better radar and cameras. They're giving AVs a much clearer picture of what's around them.
More eyes on the road, essentially.
Kind of, yeah. Then there's the AI and machine learning. This is the brain, right? Processing all that sensor data, making split-second decisions.
Like learning to drive, but way faster.
In a sense,
yeah.
You've got platforms like SigmaWave AI's TerraBuilder, which simulates countless driving scenarios to train the AI. Super realistic stuff. And Tesla's FSD V12, that's interesting, it uses end-to-end AI.
End-to-end. What does that mean practically?
It means the AI learns directly from sensor input to driving action, sort of skipping some intermediate program steps. It learns more like a human, maybe, directly mapping seeing to doing.
Okay. What else is key?
Another huge piece is connectivity. Vehicle to everything, or V2X.
V2X?
Yeah. Thanks to things like 5G, cars can talk to each other V2V. They can talk to infrastructure like traffic lights V2I, even to pedestrians' phones V2P.
So cars coordinating with each other. And the traffic lights.
Exactly. Imagine a light telling your car it's about to turn red, so the car slows down smoothly. Way better traffic flow, potentially much safer.
Okay, that makes sense. And we're seeing this tested out in the real world.
Oh yeah, loads of testing. Waymo's been running its robotaxi service in San Francisco, expanding it. Back in 2024, you had Ford and Argo AI partnering with Walmart for autonomous deliveries in places like Austin and Miami.
Right, I remember hearing about that.
And the scale is impressive. Waymo's logged over 20 million miles of real-world driving. Tesla, with Autopilot engaged, has clocked something like 3 billion miles.
3 billion.
Billion, yeah. And don't forget, China Baidu's Apollo project has over 5,000 robotaxis operating. They're a major player.
Okay, those are big numbers. Huge amounts of data being collected. But it can't all be smooth sailing, right? What are the roadblocks?
Definitely not smooth sailing yet.
Yeah.
Big challenges remain. Regulations are a major one.
The rules.
Yeah, there's just no standard set of rules. It varies everywhere. About 60% of industry execs point to this lack of regulation as a top barrier.
60%, that's a lot.
It is. Then there's public trust. Safety concerns are real, especially after, incidents like that robo-taxi accident back in 2023.
Yeah.
That kind of thing makes people skeptical, understandably.
Yeah, trust is crucial.
And infrastructure. AVs work best with really well-maintained roads, clear lane markings, reliable GPS, strong communication networks. That's not guaranteed everywhere, especially outside major urban centers or in developing markets.
And what about jobs? People who drive for a living?
That's a huge consideration. Truck drivers, there are millions in the U.S. Taxi drivers, delivery drivers. Potential job displacement is a really serious social and economic issue to figure out.
Yeah, absolutely.
And there's even an argument that AVs could make traffic worse.
Worse? How?
Well, if everyone just buys their own private AV and sends it driving around empty sometimes, or lives further out because the commute is easier, you could end up with more cars on the road, more sprawl.
Well,
One study back in 2021 projected energy use could potentially double in that kind of scenario.
wow. Okay, so it's not just about the car driving itself.
Not at all. It's about how we use them. Many argue AVs need to be integrated with shared mobility, with public transport, using them for those first and last mile connections, for instance.
Makes sense, getting people to and from the train station or bus stop.
Exactly. And like Mary Barra, GM CEO, said the biggest hurdle might not even be the tech anymore. It's public trust.
That really hits home. Public trust.
Yeah.
So looking forward, what's the outlook? Where is this heading in the next decade or so?
The market growth projections are, frankly, enormous. We're talking potential revenues of $300 to $400 billion by 2035.
Huge numbers.
Yeah. We'll likely see level 4 become much more common, especially in those controlled environments like robotaxis within cities or for long-haul freight trucking.
And those robo-shuttles you mentioned?
Right. Shared autonomous shuttles in cities.
Yep.
McKinsey suggested back in 2022 they could cut private car use in urban areas by almost half, like 46%.
That would change cities completely.
Totally. And we might see things like blockchain being used more, maybe for securing the data these AVs generate and share, enhancing that trust factor again.
Fascinating. Okay, let's shift gears. Electric mobility. This feels like it's already happening, doesn't it? Much more mainstream.
Oh, absolutely. EVs, battery electric vehicles, BEVs, and also plug-in hybrids, PHEVs, they've seen a massive surge.
Yeah.
I mean, projections for China suggest half of all new car sales there could be electric by 2025.
Half already. Wow.
Yeah. And it's driven by, well, a few key things. Environmental concerns are huge. Transportation is about 15% of global greenhouse gases, right? Plus, consumers are just demanding cleaner options more and more.
You definitely see more Teslas, Rivians, Polestars around. What makes people actually buy one? What are the big selling points?
Several things. Environmentally, zero tailpipe emissions is a big plus. Cleaner air in cities, less pollution.
Good for breathing.
Definitely. Then there's cost savings. Over the long run, electricity is usually cheaper per mile than gas. And EVs generally need less maintenance, fewer moving parts, no oil changes.
It's time at the mechanic.
Hopefully. And performance is a big one too. That instant torque from electric motors. It means they accelerate fast. Like Tesla Model S Plaid doing 0 to 60 in under 2 seconds fast.
Yeah, that gets your attention. So what's happening on the tech side? What are the breakthroughs in EVs?
Batteries. It's always about the batteries. We've already got cars like the Lucid Air getting over 300 miles of range, which is pretty solid.
Getting better all the time.
Yep. And the next big thing people talk about is solid-state batteries. They promise more energy density, meaning more range, maybe 800 miles or more, and potentially faster charging. Toyota's aiming to roll them out around 2027.
Solid state. Okay. And charging. That's always the question, right? Where do you plug in?
Infrastructure is critical. It's growing, but there's still a way to go. The U.S. has goals for more hydrogen stations and thousands of fast chargers by next year. China's way ahead, though. Already over 1 million public chargers.
1 million?
Yeah. We're even seeing cool stuff like wireless charging roads being tested in places like Detroit and Sweden. Imagine just driving over a specific lane to charge.
That would be convenient.
Very. But realistically, the U.S. still needs way more chargers. Estimates say maybe 1.2 million more needed by 2030 to keep up.
So still building out that network. Are governments helping push this along?
Big time. Policies are a huge driver. The UK banning new petrol-diesel car sales by 2030, New York by 2035. Those send strong signals.
Creates certainty for the market.
Exactly. And don't forget, micromobility, electric bikes, scooters. Super popular, especially in cities. McKinsey found about 30% of people plan to use them more.
Right, those Lyman Bird scooters everywhere.
Yeah. And look at big city initiatives. Jakarta, in Indonesia.
Yeah.
They're aiming to electrify 10,000 buses by 2030. That has a real impact on air quality and public transit.
10,000 buses, that's a serious commitment.
Yeah.
But like AVs, there must be challenges with EVs too.
Oh, for sure. Several big ones. Raw materials, for starters, lithium, cobalt, nickel, essential for batteries. There are concerns about limited supplies and ethical issues too, like cobalt mining in the Congo. That could affect how fast we can scale up production.
Right, the supply chain.
Exactly. Then, charging gaps. Still not enough chargers in rural areas, and can the power grid actually handle millions of EVs plugging in, especially overnight? That's a big question, particularly in developing countries.
Grid capacity.
Upfront cost is still a barrier for many, even if running costs are lower. EVs are getting cheaper, prices dropped maybe 18% since 2022, but they're often still more expensive to buy initially.
Sticker shock.
Yeah. And battery recycling. I'm not very good at it yet. Only about 5% of lithium-ion batteries get recycled today. Improper disposal is an environmental risk.
So we need better end-of-life solutions.
Definitely. And some critics argue, are we just shifting the environmental burden from tailpipes to mining and manufacturing the batteries?
That's a fair question. The whole life cycle impact.
It is. But most life cycle analyses still show EVs come out ahead, like 50–70% fewer emissions over their lifetime compared to gas cars, especially if the electricity grid gets cleaner with more renewables.
Okay, so still a net positive environmentally overall.
Generally, yes, especially with clean energy.
So what's the future look like for electric mobility? Where is it headed?
Well, the trend is undeniable. Projections suggest EVs could be like 85% of global light-duty vehicle sales by 2035.
85%, wow.
Yeah, massive shift.
Yeah.
We'll see more innovation, wireless charging becoming more common, maybe vehicle-to-grid systems, V2G,
V2G, what's that?
where your car can actually send power back to the grid when needed, helping balance supply and demand. Your car becomes part of the energy infrastructure.
Interesting.
And that deeper integration into mobility as a service, MaaS, platforms,
Yeah.
making it easier to combine EV use with other transport options, maybe reducing the need for everyone to own a car.
Okay, fascinating. Right, let's change perspective completely now. From roads to, space, commercial space travel. This feels like it exploded recently.
It really has. It used to be all NASA, Roscosmos government agencies. Now you've got SpaceX, Blue Origin, Rocket Lab, private companies leading the charge in many ways.
And it's not just talk anymore, right? People are actually going.
Absolutely. By now, May 2025, it's a real burgeoning industry. SpaceX is talking crewed flights around the moon. Blue Origin is doing suborbital tourist flights, quick hops up and down.
Quick hops for a hefty price tag, I imagine.
Oh yeah, definitely not cheap yet. But the significance goes way beyond just adventure tourism.
How so? What are the bigger impacts?
Well, science, for one. More launches, cheaper access.
Yeah,
It helps us explore exoplanets, study asteroids, maybe even mine them eventually.
asteroid mining. Still sounds futuristic.
A bit, but people are working on it. Economically, the potential is huge. The global space economy could hit $1 trillion by 2040.
Yeah.
Satellites, tourism, resources.
$1 billion.
Yeah. And global connectivity is a massive one right now. Look at Starlink.
SpaceX's satellite internet.
Exactly. Providing internet to remote places that never had it. By now, it covers something like 90% of Earth, serving millions of users in dozens of countries. That's a game changer.
Connecting the unconnected. That's powerful.
Yeah.
What tech is enabling this commercial space boom?
Reusable rockets are the absolute key. SpaceX's Falcon 9, now Starship, they've slashed launch costs, maybe by 30% or more.
Making it cheaper to get stuff up there.
Way cheaper. A Starship launch might be around $90 million. Compare that to the space shuttle that was like $1.5 billion per launch.
Huge difference.
Massive.
Yeah.
And space tourism is happening. Blue Origin's flights, Virgin Galactic's too, though they've had setbacks. SpaceX did that Inspiration 4 mission back in 2024. All private citizens orbiting Earth.
Right, the Netflix documentary mission.
That's the one. Plus, big lunar ambitions. NASA's Artemis program aims for humans back on the moon by 2026. And private companies are developing landers, habitats, all sorts of support tech.
A return to the moon, but with commercial partners this time.
Very much so. And there's even a focus now on space sustainability. Things like the World Economic Forum's Space Sustainability Rating, trying to deal with space debris.
Space junk. Yeah, I've heard about that. How much is up there?
Over 27,000 trackable objects. And countless smaller bits. It's a growing problem as launches increase.
Okay, sustainability in space. Makes sense. But what are the big challenges facing this commercial space race?
Cost is still a major factor. Even $90 million for a Starship launch. It's a lot of money. It limits who can participate.
Still not exactly accessible for everyone.
Not even close. Environmental impact is another concern. Rocket launches release CO2, black carbon. There's a push for greener propellants like methane, but it's still an issue.
Right, the launch footprint.
And regulations. Space law is lagging behind the commercial reality. Who governs traffic up there? Who owns resources mined on the moon or asteroids? Lots of unanswered questions.
Tricky international stuff.
Very. Safety is always paramount, too. Space is inherently risky. We saw that Virgin Galactic test flight failure in 2023. And the long-term health effects of zero gravity and radiation exposure still not fully understood or solved for long missions.
Yeah, the human body isn't really designed for space.
Not really. And then there's the ethical dimension. Should we be pouring billions into space tourism and exploration when we have so many problems here on Earth?
That's a tough one. The Earth versus space debate.
It is. The counter-argument, of course, is that space tech often leads to innovations that benefit us here, like GPS, weather satellites, material science.
True, there are spin-offs. So, looking ahead in space, what's coming next?
Lunar tourism is definitely on the cards. SpaceX talks about lunar resorts, though trips will likely cost $500,000 to $1 million initially.
A very exclusive resort.
For a while, yes. Mars missions are still the long-term goal for SpaceX, aiming for human missions maybe by 2030.
Mars still feels ambitious for this decade.
Highly ambitious. Asteroid mining startups like Astroforge are actively targeting asteroids for rare minerals. And we'll likely see more development of space infrastructure, orbital hotels, refueling stations to support longer missions.
Building the foundations for living and working off-world.
Pretty much. Like Elon Musk said, maybe in 10 years a ticket to orbit could cost less than a luxury car. We'll see.
That'd be something. Okay, so we've covered AVs, EVs, space travel. Fascinating stuff on their own. But how do these all potentially connect? What happens when these trends converge?
That's where it gets really powerful, I think. The synergies. Think about EV battery tech, right? Maybe powering those autonomous robo-shuttles we talked about. Clean, autonomous urban transport.
Okay, yeah.
Or think about space tech feeding back to Earth. The advanced GPS needed for space navigation. The sophisticated AI. That directly helps improve autonomous vehicles on the ground.
Tech transfer from space back down.
Exactly. And imagine future mobility as a service platforms. You could plan a trip that uses an electric AV for the local bit, maybe a Hyperloop or high-speed electric rail for the long distance, and who knows, eventually maybe even a suborbital hop for intercontinental travel, all booked through one app.
Wow, a truly integrated system. What kind of broader societal impacts could that level of integration have?
Potentially massive shifts. Urban design, for instance. If fewer people own private cars because shared AVs and EVs are so convenient, we could reclaim a lot of land currently used for parking. Maybe 5% of urban land freed up for parks, housing, whatever.
More green space, less asphalt. Sounds good.
Definitely. Equity and access could improve too. Affordable AVs and EVs could really help underserved communities, older adults, people with disabilities. And space tech, like satellite internet, keeps boosting global connectivity.
Bridging divides.
Hopefully. Economically, this shift is huge. Shared mobility alone could be a $1 trillion market by 2030. It completely changes the game for car manufacturers, energy companies, tech firms, creates whole new industries.
$1 trillion in shared mobility. That's transformative. But integrating all this tech must bring its own set of challenges, right?
Absolutely. Data privacy is a huge one. With V2X communication, MOS platforms, everything is connected, sharing data constantly. We need incredibly strong cybersecurity to protect that data and prevent misuse.
Protecting our movements or habits.
Exactly. Public acceptance, we mentioned it before, remains key, especially for shared AVs. Surveys show people are still hesitant, maybe only 70% open to the idea, largely due to trust issues.
Still got to build that confidence.
And the global divide. Developing nations might struggle to afford and implement the necessary infrastructure, the charging networks, the 5G, the road upgrades. There's a real risk of creating a two-tier world of mobility.
A mobility gap. We need to avoid that.
Crucial. We need to ensure these benefits are shared widely.
So painting a final picture, what's the ultimate vision here, this integrated future?
I picture cities with these seamless mobility hubs, where you easily switch between electric bikes, robo-shuttles, fast trains. Maybe space-based systems help manage traffic flow in real time using satellite data. And critically, the whole thing is powered by clean, renewable energy. a sustainable, efficient, connected transportation ecosystem.
Well, this has been quite the journey through the future of transportation. Really fascinating stuff. We've hit on autonomous vehicles, making roads safer, the electric revolution, pushing sustainability, and commercial space travel, literally reaching for the stars.
And it's happening fast. These aren't distant dreams. They're evolving right now, accelerating. They're going to change our daily lives in pretty profound ways.
For sure. Incredible opportunities, but also, as we've discussed, some really significant challenges to navigate carefully. Lots to think about.
Definitely. So maybe a final thought to leave you with.
Yeah.
As all these technologies, AVs, EVs, space tech, as they merge and reshape things, what single aspect of this whole transportation revolution do you think will actually have the biggest impact on society in, say, the next 10 years?